Okay, so in this video I'm gonna show you how to create your first CNC-ed enclosure, this metal case that you see right now, and it includes the rotor encoder module from the F-Robot, so as I turn the knob, the LEDs will light up, but without the module it looks like this, and before it was anodized it looked like this. You can see there are some visible tool marks, and before that it was just a drawing in Autodesk Fusion 360. And since today it's all about physical products, not only you can watch this video here on YouTube, but you can also read it as the article in the Elector magazine. And if you like to take a break from looking at your PC monitor all the time, I think that reading a physical magazine is a great choice. And if you use the link down in the description of this video and subscribe to the newsletter, you immediately get a $5 coupon that you can use to buy something. So with that said, let's get back to our project. I already have a video for a similar project, but today I want to create something much simpler. The last time I've used 3 rotor encoder modules, today I will use just one. You can connect this module to the Arduino using the I2C connection, but the nice thing about the module is it includes already the microcontroller, so as you turn the knob, it lights up the LEDs on its own. I wanted to create the simplest possible case into which I can put this module while still having the access to the connections on the bottom of the PCB. There are 4 holes into which I can put the screws to secure the module in place, and there is a small rim on the top of the case where I can put the acrylic overlay. So let's try to recreate something like this in Autodesk Fusion 360. But before we do so, I want to thank my friend for helping me create this version and allowing me to film the process. Please stick to the end of the video to see those clips. And I also want to thank PCBWay because they created this version for me. This is the bead blasted and anodized aluminum in grey color. So let's go all the way to the beginning and jump into the Fusion 360. I'm using the free version which is intended for hobbyists, and it has few of the limitations. One thing is that you can only have up to 10 editable documents at one time, which doesn't seem to be a big of a limitation for me. The second limitation is the formats for exporting, so some of those are grayed out, you cannot use those, but since we will be using the step file and that one is enabled, we should be fine. In here we want to start with creating a 2D drawing, the top view of our design that we will later on extrude to create a 3D shape. To create a new 2D drawing, we will click the Create Sketch button and create a new sketch on the bottom plane, so clicking this plane will create a sketch from the top view. Which you can also tell by this cube, so it's saying top, so we are looking from the top onto our sketch. In here we can create all kinds of shapes, we can modify those and add some constraints, but let's not worry about those for now. You can draw any of the shape by clicking the button in the toolbar, then pressing the left mouse button to place the first corner, and then you have 2 options. You can either type in the dimensions using the keyboard, and you switch between the fields using the tab key, so 30mm for the height and 50mm for the width, then pressing the enter key will create a rectangle, or you can draw the shape without actually specifying the dimensions, so I'll left click to place the first corner, and then left click again to place the second corner. And as I select the selection tool, I can move those lines individually because those are not constrained, but for the left shape I will be moving the entire rectangle because now the dimensions are being set, so if I want to change the size, I have to double click the dimensions and type in the different value. And I think the rectangle is a great starting point because our module looks like a rectangle from top or like a rounded rectangle from top. So I'll get rid of those 2 rectangles and draw a new one, but I want to draw it from the center, so I will click Create a Rectangle, a Center Rectangle, and then click on the origin and type in the dimensions. And I've already measured the size of the board. It seems to be around 37 by 37 millimeters. So this will be our starting shape. Now it's important to say that there are 2 types of lines in sketches. One of them are normal lines and the other ones are the construction lines. So the normal lines are solid like this one and the construction lines are dashed like those ones. And as the name suggests, those construction lines are only helper lines, they will not be used to create 3D objects. And that's actually the case for our rectangle. So this is the shape of our board, but I will not use it to create a 3D shape because I want to first offset it. So for this initial rectangle, I can also select all of those lines and use this button on the sketch palette to turn those into construction lines. So now everything is dashed. I want the corners to be rounded, and that could be easily done by using the fillet tool, but I don't know what should be the value, so let's talk about this first. And if you look closely on the module, you can see that the radius on the PCB is kind of matching the holes. So if you offset the hole, you get the radius of those corners. And if I use the caliper, I can measure that the center of the hole is about 3.5 millimeters from the edge, and the size is about 3 millimeters. So let's try to visualize what's going on. I will quickly use the offset tool to offset this outer rectangle by 3.5 millimeters. And you don't have to do this, this is just for visualizing. And so here on this position, we have a hole of diameter of 3 millimeters, and we want the outer radius to match this hole. So if I draw a second hole, I can see that if I touch this outer edge, it's 7 millimeters. So if you want to get this exact round corner, the radius will be 3.5 millimeters, which is of course the distance of the hole from the edge. So let's undo all those steps, and we can apply the rounded corners by clicking this fillet button and then selecting those individual lines and typing the value of 3.5 millimeters. I want to offset this slightly so the sides of the enclosure are not touching the sides of the PCB tightly. And for that I will click the offset tool and click our outline, and then I can use this arrow to move it inside or outside. I want to have it outside, but probably by only 0.5 millimeters. That will be the inside shape of the enclosure. For the outside shape, I want to offset once more. So again, I will select the offset tool, select our construction line and offset it by 3 millimeters outside, so minus 3 millimeters. Those will be the walls of our enclosure. And I believe that we have enough to create some 3D shapes. So I will click the finish sketch. That will close the sketch editing, and I can rotate the view to see the 3D view, and I want to extrude some stuff. I want to first extrude everything to create the base for our enclosure. So I'll click the extrude tool and select everything and type in, for example, 2 millimeters for the bottom side of the box. I want to also offset the sides, so I'll click the extrude tool one more time, but you can see that now I cannot see the sketch because it's been hidden. So I have to show the sketch, and maybe I can also hide the body. So I can easily select the side like this and type in 6 millimeters. Let's take a look at the options, and you can see that the operation is set to new body, so it will create a new 3D shape. Instead, I want to have it connected to the body 1. So what I will do is I will show the body 1 and change the operation to join, so it will end up as one shape. Now we haven't really talked about how tall the shape should be, but I talked with my friend who has a CNC machine, and he told me he will help me as long as I keep the height to 15 millimeters, because he had some leftover blocks lying around in the size of 15 millimeters. So this is the size I will go with, and of course first I've measured the size of the PCB of the module to make sure that I can somehow fit into this size. So click the OK button, and now we have a base for our 3D object. Now it looks somehow strange around this area. That's because the sketch is being displayed. It looks much better if you hide it. If you want to rotate the 3D view, you can use this helper cube, but you can also use the middle mouse button together with the Alt key to move it, Shift key to rotate it, and mouse wheel to change the zoom level. One thing that I like to do is to change the material, because the default one is kind of dark. So I'll right click the body and select appearance, and in this dialog I will open metal and aluminium and select one of those aluminiums without being anodized, for example this one, the solid one, and simply drag it over the shape or over this body. That's the same thing. You can see it's a little bit lighter, and I like how it improves the contrast between the lines and the fill. I can close the dialog and we can move on. At this point I want to create some supports for the board, so create some stands which later on will have some holes for the screws, and again we will need to create a sketch. Now we can create a new sketch by clicking this create sketch button, or we can reuse the older one, which is something that I will do. So I will hide the body and show the sketch, and then double click the sketch to switch into editing mode. We already know the positions where the holes should be placed. Those are those 4 points. And we know that the hole size is 3 millimeters, so in order to create some kind of stand, we need to draw a circle that will be somehow bigger than that, so at least 4 millimeters, probably even more. But if I create a hole, for example 5 millimeters, there will be a very small space around here where the tool will have to eventually come in there. So what I think that I will do instead is I will connect this stand together with the outer shell. And to do that, I will draw the circle big enough to be touching the outer shell. So draw a new circle from this point until it will eventually touch the outer shell like this, which is a diameter of 8 millimeters. Now it's even worse because it's impossible to fit the tool into this area. So what I will do instead is I will just close it with some lines. So I'll select the line tool and draw a line from this point to this point. And there are a few ways how to do this. You can do this manually by clicking anywhere on the circle and anywhere on the line, like so. And then I want to constrain this line. So I want to make sure that this line is tangent to the circle. So I'll click the tangent constraint and click the line and then the circle. And then I want to make the line horizontal or vertical. So I'll click the horizontal/vertical and click the line again. I can do the very same thing for the second line. So again, line, touching the circle and touching the outer shell, and then clicking the tangent constraint between the line and the circle, and horizontal/vertical for the line itself. If I don't want to set the constraints manually, I can try to force Fusion to do this for me. So for the next support, I will again draw a new circle from this point in the diameter of 8 millimeters. But for the line itself, I will try to move it into the position where the Fusion 360 will recognize that some constraints need to be added. So I'll click the line and move my cursor cursor next to the center of the circle and then move the cursor slowly to the left side until I will reach the circle. So you can see there is this first point being placed, and then move my cursor to the top, trying to make it straight until I'll reach the outer shell and then click again. And similarly, you can see that the Fusion also created the tangent constraint, but it created this one, which is the perpendicular constraint. I guess both are the viable options. So let's create the second line in the same way. So move the cursor to the middle of the circle, move it down, touching the circle, and then move it to the right side. And we can create the other two supports in the same way, or we can try to mirror those on the top. And in order to mirror something, we need a construction line which will be used for mirroring. Let's draw a new line by clicking the line button and then moving the mouse cursor over the origin, then to the left side, start drawing the line and draw it to the right side. And we don't need to specify the dimensions. I will press the escape key to stop drawing, but I want to select the line and set the line to be the construction line. And I can even center the line by clicking this midpoint constraint and then clicking the line and the origin. And let's use the line for mirroring. So select create mirror. Then the first thing we need to select are the objects. So select all the circles and the corresponding lines. So circle and those two lines, and circle and those two lines. Then click the mirror line and select our helper line and click the OK button. We can finish the sketch and try to extrude those supports, but before we do so, we have to of course measure how much we want to extrude those. And I want the PCB to be sitting on those supports, while the connector should be almost on the ground. And the connector is about 5.8 millimeters tall, so let's make those 6 millimeters. So in Fusion, I will select the extrude tool and I will select all my supports, so all the circles and those shapes next to the circles. I will set the distance to 6 millimeters, but before clicking the OK button, I want to connect this to the previous body, to the current body that we have, which is the body 1. So I will show it and make sure that the operation is set to join and then click the OK button. Those supports should have holes inside for screws, so let's add those. And I can show the sketch and try to add a hole using the hole button. So if I click the hole and click this point, it will give me a hole, but it will only go down. So the hole will go downside, which is not making a difference, of course. So what I want to do is I want to add the hole, but actually starting on the support top plate. You can see there is error. It's saying no, nothing to intersect with. So let's cancel this and create a new sketch instead. So I'll click the create sketch and I will create the sketch on one of those supports. So clicking this plane, it will create me a new sketch on the top of the support. And what I want to do is I want to project those 4 points for placing the holes into our new sketch. And it might be a good idea to hide the body and only keep the sketches visible and maybe rename those to some meaningful names. So this one is sketch for holes. This will be sketch for main shape. So inside our sketch for holes, I will select create, project, include, and project. And I want to project those 4 points. So 1, 2, 3, and 4. And click the OK button. So now when I hide the sketch for the main body shape, you can see that I still have those 4 holes. And if I show it again, you can see that those 4 holes are actually placed above the surface on the position of the extruded supports. So what I can do now is to finish the sketch, hide the sketch for the main body shape and show the body, and click the hole button to create a hole into our surface. Click all of those individual points. And by default, those holes are very big, but we'll fix it in a minute. And in this dialog, I will select tapped hole, and from the presets, I will select 3 millimeter hole, which is the correct diameter, but the holes are still going outside of our shape. So we need to fix the depth. So instead of 14 millimeters, we can either use this arrow or we can type in the value, and I think that 4 millimeters should be enough. So click the OK button, and now we have holes inside our supports. We want to also create the holes for the connectors on the bottom of the PCB, and there are 2 connectors in there. When measuring the size, it might be a good idea to connect the wires because those pins also take a little bit of space. So the bigger connector seems to be about 12 millimeters, and just to stay on the safe side, let's make the hole 14 millimeters, so 1 millimeter extra space on each side. The second connector is wider, it's about 10 millimeters. And again, let's add 1 millimeter to have a little bit of breathing space. And to make things simpler, let's actually use the same hole size for both connectors. So back in Fusion, we need to create a new sketch, but instead of doing a new one, I think that I will reuse this sketch for the main body shape. So I'll show it, hide the body, and double click the sketch to jump into the editing mode. And inside here, I want to create 2 holes. So for that, I will need the rectangle tool. So select the rectangle tool. And as we've just measured, the width should be 11 millimeters, while the height should be 14 millimeters. However, we also need to account for the thickness of the wall, which is 3 millimeters. So the width should be 11 plus 3 millimeters, which will be also 14 millimeters. To align this properly with our shape, I will use the midpoint constraint. So midpoint of this line together with this line, we'll move it to the right side, and we need one more rectangle of the same size, so create a new rectangle, again that will be 14 by 14 millimeters, and use the midpoint constraint from the left side to the left side of the enclosure. So finish the sketch and we can try extruding those. And cutting is actually part of extruding, so I'll select the extrude tool and select our holes, which are made from 2 rectangles. Then I will show the body and insert a distance of 6 millimeters, so the same distance as for the supports. By default, the operation is set to cut, which is exactly what we want. So I'll just click the OK button and we should get holes inside our enclosure. It looks like the bottom here is still being connected. That's just the sketch. So if I hide the sketch, you can see that the shadow is coming in our way, but there is actually the hole, so nothing is being there. It's better visible from the bottom. So we have holes for our connectors. We have stands with the holes for the screws. The only missing piece is the rim for the acrylic glass, which will fit inside the enclosure. And that's a simple thing to do. So I'll create a new sketch. So click the create sketch on the top of the enclosure. And let's name the sketch sketch for rim. Hide the body so we can only see the sketch, and I want to offset this shape by a certain amount. And if I use the inspect measure tool, I can measure that the distances between those two lines are 2.5 millimeters. So let's just, for example, say that the rim will be 1 millimeter and the rest of the part where the acrylic glass will sit on will be 1.5 millimeters. So I will close the measuring and use the offset tool and offset the shape by minus 1.5 millimeters for the stand and 1 millimeter for the rim. Finish the sketch and we can extrude this rim downwards. So again, cutting the shape into our body. Select the extrude tool, select the inner part of the rim and set the distance to 2 millimeters, actually minus 2 millimeters to cut the hole into the enclosure. Make sure that the operation is set to cut. We are cutting body 1 and click the OK button. At this point, our 3D shape is done, but we can still fix some nuances. And by that, I mean smoothing some surfaces. Because if you think about how the part is being manufactured, there is the tool coming from the top, and something like this, like the sharp corner inside, will be very hard to manufacture, actually impossible to manufacture, because the tool has some radius, so it will not be able to create a sharp corner. And we actually don't really need to have a sharp corner in here, so we can use the flat tool and just make this a little bit rounded, like so, maybe, by 3 millimeters or so. And we can do this for all the sharp corners inside. Something that might be slightly confusing is once you set the value, you cannot click any other line. You have to hold the Control key to add a line to the selection. And so I'll do this and I will select all the other corners. Again, by holding the Control key and clicking those individual lines. And as I'm holding the Control key, you can set the effect of the fillet tool. But once I release the key, you will see it being drawn. So again, those two, I will rotate the view, select those two and rotate the view one more time and finally select those two. And not only this will help with manufacturing, but I think that it also looks nicer. So I'll go with, for example, with 3 millimeters, click the OK button. There is also a sharp corner inside where we've created the holes on the bottom of the enclosure. Those are those lines. So again, I will select the fillet tool and select this line as well as this line and those two lines on the other side. And I will go with probably maybe 2 millimeters. Again, to me, it also looks nicer. We also want to avoid any sharp edges on the outside, and there are multiple of those. And one of the sharpest part is this part, where you can see that everything is sharp. So we can try to round it at least a little bit. Select the fillet tool and select this line and make it slightly rounded, maybe like 1.5 millimeters. And use the same value also for this corner and those two corners on the other side. So this one and this one. Now a quick way how to remove sharp corners on the outside is to use the chamfer tool. So from the modify menu, I will select the chamfer and select this edge and chamfer it to maybe like 0.5 millimeters. In the same way, I can use the chamfer on the other side, on the top side of our enclosure. And probably the edge that I care about most is this outer edge. So I'll select modify chamfer, this outer edge and set some very small value, maybe 0.1 millimeters. And I think that at this point we have everything that we need to for our enclosure. Now, if I decide I want to change something, I can of course do this. And if it's something inside the sketch, I can just open the sketch. So for example, this main sketch, I can double click and edit it. And maybe I don't like the thickness of the walls. Maybe I want to make it much bigger. So maybe instead of 3 millimeters, I can type in 5 millimeters. And as I finish the sketch, I should see the main shape being updated. So now the walls are much thicker. If I want to change anything that's not related to the sketch, there is this timeline on the bottom, which shows all the individual steps. So I can go back in time and I can change the values for anything I want to change. So let's say that, for example, one of those extrusions, I want to make it different. So maybe this one for extruding the stands, I want to make it bigger. I can right click this icon and select edit feature and set a different distance, for example, 8 millimeters instead of 6, and then go forward in time and everything hopefully should look how it should look. That said, I don't want to make those changes, so I'll undo it to the original state. So 6 millimeters for the stands and the walls should be only 3 millimeters, not 5. And at this point, I think that we can export this for manufacturing. And that's simple. We only need to select File, Export, select the file format to be the step file, give it some meaningful name, and hit the export button. As mentioned already in the beginning of the video, I have a friend who has a CNC machine and he was kind enough to help me with this project. I was also able to capture a few of the video clips, but only a few for a certain reason. And the reason are all those small chips flying all over the place. As you can see in here, the CNC enclosure was faded and scratched, so when the enclosure was closed there were no chips flying around, but unfortunately it was kind of hard to see what's going on. So at this point the CNC machine is removing the inner part of our enclosure of our case. It starts in the middle and it goes outwards, making sure to keep the supports in place. Here it creates the rim, and after that it will jump to the outer part, meaning that it will remove the material from the outside, keeping those 3mm walls. And let's speed it up a little bit to see how it looks like when a lot of material is being removed. Here is the next part where the threaded holes are being created for the individual screws. Again, let's just speed things up a little bit, and I promise that the next time I will bring a tripod. And so once the first side is done, it's time to flip it and put it inside the vise. And so here's the CNC machine doing some measuring to make sure that everything is on the right level. As for the bottom side, we need to create those big holes for the connectors. It takes a while, so I'll speed it up a little bit. And then probably the most satisfying part is removing all those ugly leftover parts, while at the same time creating the chamfering on the bottom of the enclosure. And that's pretty much it. That's the whole CNC process. So let me say a few final words about this project. Again, the left enclosure is done by my friend, the right enclosure is done by PCBWay, and there are actually 3 differences between those 2 parts, not counting the surface treatment, because this is how it looks like directly out of the CNC machine. This one was after that bead blasted and anodized with the grey color. So as for the differences, the first one is that I haven't done any rounding on those edges, and as a result they are very sharp, so I've fixed it in the second version. The second difference is the distance between the PCB and the enclosure. I've originally started with 1mm on each side and that was probably too big, so I've lowered the distance to only 0.5mm, but I feel like that it could be even slightly less. The last difference is about the rim size for the acrylic glass. In the first version the extrusion inside is only 1mm, so when you put the acrylic glass over the enclosure it just sticks out quite a lot. It's 2mm for the second version, so the acrylic glass is more inside of the case while still not touching the module. If you want to know about the price, the left one costs about 3 beers, the one from the PCBWay is around $37. If you like this video and want to learn more, please watch this video where I describe the process of different CNC parts, but again using the same rotor Enclosure modules together with Arduino Leonardo. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching and I hope to see you soon. Thanks and bye.